Test coupon, the weld joint, plate or pipe, prepared specifically for a qualification test. Test specimens are cut from the test coupon for mechanical testing. Critically, the test coupon is not used in production. It exists solely for the qualification test. This is the source document from which bend test bars, tension test bars, impact test specimens, and macro sections are extracted. Weld metal, the portion of a fusion weld that has been completely melted during welding. It consists of diluted base metal plus added filler metal, along with any inclusions from flux in processes like SAW. Characterized chemically by the A-number system. Welder, the code definition, one who performs manual or semi-automatic welding. The welder manually controls the arc and the weld pool. Examples: SMAW stick welding, full manual. GTAW TIG welding, manually fed filler rod. GMAW MIG in short circuit or semi-automatic mode. Wire feed is mechanized but the welder controls travel and arc. Welding operator, one who operates machine or automatic welding equipment. The equipment controls the arc, the operator sets parameters and monitors. Examples: SAW submerged arc welding, machine-driven, wire feed and travel automated. Robotic welding cells, electroslag welding, fully automated GMAW. The welding operator does not manually control the arc, and as a result, the essential variables for welding operator performance qualification are fewer than for a welder. There is no manual dexterity component to evaluate. Weld progression, the direction of welding, uphill or downhill when welding in the vertical position. Vertical up is 3G ascending, vertical down is 3G descending. For some processes and certain materials, particularly on root passes in pipe, the direction of weld progression is an essential variable. Vertical down welding tends to produce a faster, more fluid puddle that can increase the risk of lack of fusion defects in some materials, which is why some procedures restrict or specify progression direction. This slide deserves its own stop because this particular distinction is one of the most commonly confused points in Section 9, and getting it wrong leads directly to invalid qualification tests and audit findings. The three categories are welder, welding operator, and tack welder. Let me give you the code level definitions and then the practical implications. Welder, a person who performs welding operations where the quality of the weld depends primarily on manual skill and dexterity. The welder is in direct control of the arc, the torch, and the filler metal feeding. Process examples: SMAW, full manual. GTAW, manual torch manipulation and manual rod feeding. GMAW in semi-automatic mode, the wire feeds automatically but the welder guides the gun. Oxyfuel welding, performance qualification for a welder is governed by WQ 350 in Article 3 of Part QW. The WPQ form is QW 484. Essential variables for a welder include position, base metal P number, filler metal F number, process, thickness range, and diameter range for pipe. Welding operator, a person who operates automatic or mechanized welding equipment. The equipment controls the arc, the operator monitors and adjusts set parameters. The welder's manual dexterity is not a significant factor in outcome quality. The machine's setup is. Process examples: SAW, the machine drives the wire and moves the torch. Robotic welding cells, electroslag welding, fully automated GMAW. Performance qualification for a welding operator is governed by QW 360. The WPQ form is QW 485. Because the machine does the work, the essential variables for a welding operator are fewer and focused on machine setup parameters rather than positional skill. Tack welder. This is the one that catches people out in quality audits. A tack welder makes temporary welds to hold parts in position for final welding. Whether that person needs to be qualified depends entirely on what happens to the tack weld. If the tack weld is incorporated into the final weld, that is, it becomes part of the completed joint, the person who made it must be a fully qualified welder. Section 9 treats it as a production weld because it ends up in the finished product. If the tack weld is removed before final welding, ground out, arc gouged out, or otherwise removed prior to final welding. No formal qualification is required by Section 9. The tack is not in the final product. In practice, most companies require that all tack welds be made by qualified welders regardless, because field conditions make it difficult to guarantee that every tack weld will be fully removed before welding is complete. Bridge tacks in particular, tacks used to maintain root opening in pipe joints, are almost always left in place and are definitely incorporated into the final weld. Those absolutely require a qualified welder. The record forms. Welder Performance Qualification uses QW 484. Welding Operator Performance Qualification uses QW 485. If a tack welder is making incorporated tacks, their qualification record is the same as a welder, QW 484. This slide covers the 4 weld type definitions that control qualification scope. This is important because qualification for one weld type does not automatically qualify another, with one notable exception that I will explain. Groove weld. The code defines a groove weld as a weld made in a groove formed within a single member or in the groove between two members to be joined. Groove types range from the simple square groove to single and double V, U, J, bevel, and flare configurations. Groove welds are the primary structural and pressure-carrying welds in pressure vessel and piping construction. Test requirements for procedure qualification include a tension test and guided bend tests, face bends, root bends, or side bends depending on thickness. The performance qualification test for a groove weld uses bend test specimens or radiographic examination. Fillet weld. The code definition. A weld of approximately triangular cross-section joining two surfaces approximately at right angles to each other in a lap joint, T-joint, or corner joint. Test requirements for fillet weld procedure qualification are different. They use a fillet weld fracture test or macro etch under QW 180. No tension test is required. Here is the critical qualification transfer rule. A groove weld qualification automatically qualifies fillet welds of unlimited size. This is stated in QW 451.2. If your WPS is qualified for groove welds, you do not need a separate fillet weld qualification. The groove weld test is more demanding, so the code treats fillet welds as covered. The reverse is not true. A fillet weld qualification does not cover groove welds. If you only have a fillet weld procedure qualified, you cannot use it to make a groove weld. I want you to remember this rule because it comes up constantly when reviewing WPS scope coverage. Overlay and cladding. Overlay is deposited weld metal applied to the surface of base metal, not to join two members, but to provide a functional surface. Corrosion-resistant overlay uses a compatible alloy to protect the base metal surface. Hard-facing overlay uses a harder material to resist wear. Overlay qualification is entirely separate from structural weld qualification. An overlay WPS cannot be used to make a structural groove weld. Qualification test requirements for overlay under QW 453 are different from those for structural welds: corrosion testing for CRO, hardness testing for hard facing. Stud weld. A weld that attaches a metal stud or similar threaded component to a workpiece. The two methods are arc stud welding and capacitor discharge stud welding. Used for shear connectors in composite construction, insulation anchors, lifting lugs, and similar applications. Stud welding qualification is separate from all other weld types. The essential variables include the process, arc versus capacitor discharge, the stud material, the base metal, and the stud diameter. Test requirements include bend tests, torque tests, and macro etch under QW 192. These 4 thermal parameters, PWHT, preheat, interpass temperature, and heat input, appear on essentially every PQR for structural and pressure-containing welds. Let me go through them in the depth they deserve. Preheat temperature. The code definition: the minimum temperature in the weld joint preparation immediately prior to the welding, or in the case of multiple pass welds, the minimum temperature in the section of the previously deposited weld metal, immediately prior to welding. Preheat is applied within 75 mm, 3 inches, of the joint on each side before welding begins. The purpose is to slow the cooling rate of the weld and has, preventing the formation of hard, brittle microstructures in materials sensitive to rapid cooling, particularly higher carbon and alloy steels. For variable classification, a decrease in the minimum preheat temperature is an essential variable under QW 406.1. Decreasing preheat increases cooling rate and can change mechanical properties, so it requires a new PQR. An increase in preheat is not an essential variable because it is conservative. Slower cooling generally improves properties. Measurement methods: contact pyrometer, temperature indicating crayons such as tempule stick, or infrared thermometer. Whichever method is used in the qualification test should be documented on the PQR. Interpass temperature: the code, for multiple pass welds, the temperature in the previously deposited weld metal or adjacent base metal, typically within 25 mm, immediately before the next pass is started. The maximum interpass temperature is what the code controls. If the weld area gets too hot between passes, the accumulated heat can effectively temper the earlier passes, altering their microstructure in ways that reduce toughness. Maximum interpass temperature is a supplementary essential variable under QW 406 when toughness testing is required. In practice, on heavy section welds in thick pressure vessel shells, monitoring interpass temperature requires discipline. A pyrometer or thermocouple contact reading taken just ahead of the arc before striking each pass. This must be documented during the PQR test. Post-weld heat treatment, PWHT. The complete treatment, controlled heating of the completed weld assembly above a specified temperature, holding at that temperature for a calculated soak time based on thickness, followed by controlled cooling at a specified rate. Metallurgical purpose: stress relief, has tempering, toughness improvement, reduction of hydrogen content, reduction of susceptibility to stress corrosion cracking. Variable classification: addition or deletion of PWHT is an essential variable. Change requires a new PQR. A change in PWHT temperature range is also an essential variable. The heating rate and cooling rate are specified in the construction code, typically ASME Section VIII for pressure vessels, and must match what was used in the PQR test. Heat input formula: kilojoule per millimeter equals I times V times 60, 1000 times S, where I is amps, V is volts, and S is travel speed in millimeters per minute. Let me walk through why this matters physically. High heat input, meaning slow travel at high current and voltage, puts more energy into the base metal per unit length of weld. That energy creates a wider and deeper has, slows the cooling rate, and increases the peak temperature experienced by the has material. For ferritic and carbon steels, this can lead to grain coarsening in the has, which reduces toughness. For stainless steels, high heat input increases chromium carbide precipitation risk in the sensitization temperature range. Low heat input, fast travel at lower parameters, means less total energy into the base metal, faster cooling rates, a narrower has, but also higher hardness risk in quench-sensitive steels. Heat input change beyond the qualified range is a supplementary essential variable when toughness testing is required. For toughness-sensitive applications, the heat input range qualified on the PQR must be respected in production welding. On the PQR, actual amps, volts, and travel speed must be recorded and the heat input calculated and documented for every applicable pass. On the production WPS, the qualified range must be stated so the production welder knows the limits. This slide is your reference summary. All the key QG 109 terms are here in one place, 2 columns, alphabetical. I am going to run through this at a pace designed for you to absorb it. If you are watching the video, this is worth pausing to read through. If you are using the course materials, this is the slide to print and keep next to your copy of the code. Let me call out a few that are particularly important in practice and that students frequently confuse. Backing versus retainer. Backing supports or fuses into the weld root. A retainer is non-consumable and contains the weld pool shape. Both are tracked as variables, but they are different things. Do not call a ceramic backing tile a backing, in the code sense unless it is placed at the root to support the pull, which it is. But do not confuse it with a steel permanent backing bar that stays in the joint. Defect versus discontinuity. A discontinuity is any interruption in the typical structure of the material. A defect is a discontinuity that renders a part unable to meet acceptance standards. In other words, all defects are discontinuities, but not all discontinuities are defects. An inclusion smaller than the acceptance limit is a discontinuity, not a defect. Get this wrong in an NDE report and you will have a conversation with your AI. Welder versus welding operator, covered in detail in slide 8, but see them side by side here. Manual skill versus machine operation, different WPQ forms, different essential variable sets. Weld metal versus deposited weld metal. Weld metal is all the metal in the fused zone. It includes diluted base metal. Deposited weld metal is specifically the filler metal that was added. The A number classification applies to deposited weld metal chemistry. Take a moment to review the full table. These are the terms you will encounter throughout all 18 lectures in this series, and understanding them at this stage will make everything else click faster. This is a milestone. This table covers every paragraph of Part QG, QG 100 through QG 109, mapping each one to its title, its key rule, and which lecture it was covered in. Let me read through it one time so you can confirm your understanding of the full picture. QG 100, Scope. Section 9 applies to Sections 1, 3, 4, 8, 11, 12, and B31 piping codes. WPS, PQR, and WPQ are transferable across ASME codes. Section 9 sets the floor. The referencing code may add requirements on top. QG 101, Procedure Specifications, the WPS. Must describe all essential, supplementary essential, and non-essential variables per Article 4. Must reference its supporting PQR. Must exist before production welding starts. QG 102, Procedure Qualification Records, the PQR. Records actual welding variables and test results. Cannot be altered after certification. One PQR can support multiple WPS. The test laboratory must be acceptable to the manufacturer. QG 103, Performance Qualification Records. Manufacturer retains WPS, PQR, and WPQ. All records available to the AI on request, no advance notice. Retain permanently as best practice. QG 105, Variables. Essential requires a new PQR. Supplementary essential requires a new PQR only if toughness testing is required. Non-essential requires WPS revision only. Special process variables per QW 280 series. QG 106, Organizational Responsibility. Each manufacturer qualifies their own procedures. Cannot adopt another company's PQR. WPQ has limited portability. Manufacturer supervises and certifies tests. QG 107, Ownership transfers and ISO cross-qualification. ISO 9606-1 and ISO 14732 qualifications accepted under conditions set in Appendix L. Manufacturer formally accepts and documents. Variables must fall within ASME ranges. Existing qualifications transfer with ownership changes under defined conditions. QG 108, Previous editions. Existing WPS, PQR, and WPQ from any previous edition remain valid. New qualifications must comply with the current edition. Record the edition on PQR and WPQ at the time of qualification. QG 109, Retesting. Immediate retest. 2 additional specimens, both must pass. Option 2. Practice before retest. Mandatory retest if there is specific reason to question ability. QG 109, Definitions, 40+ terms. All terms defined here take precedence over common usage. Key terms include manufacturer, contractor, welder, welding operator, WPS, PQR, WPQ, PWHT, heat input, preheat, has, groove weld, fillet weld, and overlay. Part QG is complete. 6 takeaways from Lecture 2. 1. ISO 9606-1 and ISO 17432 qualifications can be accepted under ASME Section IX, but only through the mechanism in Appendix L. The manufacturer must verify the variables fall within ASME ranges, ensure the test was conducted under proper supervision, and formally document their acceptance decision. It is not automatic, and the manufacturer takes on full QG 106 responsibility when they accept it. 2. Qualifications from any previous edition of Section 9 remain permanently valid. You do not need to requalify existing WPS and PQR documents every time a new edition comes out. New qualifications use the current edition at the time of testing, and record the edition on your PQR every single time. 3. Failed tests allow an immediate retest using 2 additional specimens. Both must pass. No additional training is required before the immediate retest, but you do not get credit if only one of the 2 retests passes. Both must succeed. 4. QG 109 definitions are code-specific. Manufacturer, welder, groove weld, and heat input all mean precisely what QG 109 says they mean. Common usage does not override the code definition. In a qualification dispute, the code definition is what the authorized inspector will use. 5. Groove weld qualification automatically covers fillet welds, but fillet weld qualification does not cover groove welds. These are separate weld types with different test requirements, and the coverage only goes one direction. 6. The 4 thermal variables, preheat, interpass temperature, PWHT, and heat input, appear on essentially every PQR for structural and pressure applications. PWHT addition or deletion is an essential variable. Preheat decrease is an essential variable. Heat input change beyond range is a supplementary essential variable. Know these cold, they come up in every procedure review. In the next lecture, Lecture 3, we leave Part QG behind and move into Part QW. We will cover QW Article 1, Welding General Requirements. That is where we go deep into weld positions for plate and pipe, test positions from 1G through 6GR, and the types and purposes of all the tests and examinations used in Section 9 qualification. It is a visual lecture, positions and test setups are much easier to understand with diagrams, so look forward to that. Thank you for watching. Subscribe to Weld Fab World on YouTube, and find the written reference material at weldfabworld.com. I will see you in Lecture 3. Part QG is fully covered. All 10 paragraphs, QG 100 through QG 109, are done. Every general requirement that underpins parts QW, QB, and QF rests on what we covered in Lectures 1 and 2. All code references in this lecture series are from ASME BPVC Section 9, 2025 edition, the QG paragraphs, Appendix L for ISO cross-qualification, and the QW 482, QW 483, QW 484, and QW 485 forms in Appendix B. This material is for educational purposes. Always refer to the current edition of ASME BPVC Section 9 for official requirements applicable to your project.